Hello everyone. Today I will design a eccentric footing, isolated footing. So let's start. So here is the data of the footing. So let's read the question first. At first, here is given the design the eccentric single footing whose depth is 7 to 1 kip and live load is 11 kip and soil bearing capacity is 1.92 ks and column size is 14 by 14 inch and column is placed 2.5 feet away from the property outline. At first, we have to know what is the eccentric footing. In the practical field, when we will assume here is our building plan, we have seen there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here are 12 column is placed or footing is placed on this property. But when when the property line is very layered, when the footing property line is very closer uh, to the property, then we will need to design the footing as a eccentric. Let's see the plan how we have called this eccentric. We have seen here the property of the plan is here. The footing will be placed along this property line. Now how we will do to place this footing along the property line from 2.5 feet is a fixed. We have only 2.5 feet distance from property line. So that's why we will choose the eccentric footing. Okay, let's start. Here is the footing area. We have calculated the footing area at first. The footing area is 1.1 dead load plus live load divided by soil bearing capacity, and we have found 46.96, which is 6.85, or similarly 7 feet by 7 feet. So here is our initial dimension of the footing is 7 feet by 7 feet. 7 feet by 7 feet. Now we will draw the layout plan. Why we will draw the layout plan? Because we have found the dimension of the footing. So if we draw the layout plan, we will get the value of eccentricity, which is very important for our eccentric footing design. Now we will see how we will find the eccentricity. Okay, so here is our dimension layout. The new layout. The eccentricity is 5. We have found the 7 feet by 7 feet as the 7 feet x direction and y direction is 7 feet. So we have divided this footing, which is 3.5 feet is here, 3.5 feet, and rest of the dimension would be 3.5 feet. But the 2.5 feet is fixed because the perimeter property line we have earlier found that the 2.5 feet is fixed. So we have deducted this 2.5 feet from center of the column and then found the value of 1 feet. But we will deduct the another value, which is half of the column dimension. So the value will be 1 feet, means 12 inch C, and 12 inch C will be deducted by half of the column. So here is a 12 inch C and half of the column is 14 inches and found the 5 inches. The eccentricity is 5 inches from column face to the CG of the footing. This is called our eccentricity. So now we'll see the L by 6 is found 14 inches So eccentricity is less than the L by C. So soil bearing pressure is isolated to will be isolated. Okay. So now we will find the pressure of the soil bearing soil pressure. This is the P by A plus 6m P by L square. M means force into distance, which is perpendicular to force into distance will be moment, and B by L into B into P by B into L plus 6 P into E divided by B into L square. Here B and L we have found the we have already found all dimension are same as 7 feet by 7 feet. Thus we will B and L with the same value. B by L will be same value. So we have found 2.27 KSF, which is greater than soil bearing capacity 1.92 in found from SPT or given in our question. Okay. So as we have shown, the our soil pressure is uh, greater than the soil bearing allowable soil bearing capacity. That's why we have to increase the size of footing. The footing size must be increased. Okay, so let's calculate again for footing size. Here is the same formula we have used. Soil pressure equal to P by P into L into 6 into P into E into PL square. We have put this value. Remind that here is B into L we have put in here as the same value. L is 7 feet and B is 7 feet. That's why we have put in the value B square and B cube. Okay, and we have found 7.58 feet, which is nearly 8 feet by 8 feet. Now our footing new dimension is 8 feet by 8 feet. So if we found the new dimension of the footing 8 feet by 8 feet, so what will be our its eccentricity? So let's see how we will calculate the new eccentricity. So again, draw the layout plan. Draw the new layout plan. Here is our new layout plan. No, we will not drawing here unless find the E value. We have shown the how we will calculate the value of E. We have found 8 feet by 8 feet. Here is 8 feet and 8 feet. So we have divided two portion. Here is a 4 feet and another is 4 feet. So 4 feet is here. So another 4 feet we have found how we will calculate the value of E. So we have shown here the another value of right portion is will be 4, but 2.5 is fixed because our property line we have shown here. The property line is along away from the 2.5 feet. So that's why our 2.5 feet is fixed. Okay, so if we found the 2.5 feet is fixed from column dimension to the property line, then what will be value will be the CG of the footing from column face. So we have found his 2.5, then another will be 1.5. So 2.5 in 1.5 will be 4. There is a 4 and another 4. So total is 8. Here is a 4 feet in right portion and another is 4 feet. Left portion is 4. But we have found the here column CG of the column to the right portion of the footing is 2.5 feet, which is fixed as a client requirement. So we will calculate how we will get the column face to the CG of the column, CG of the footing. This is our eccentricity. So we have found there here is the value of 4 feet, 1.5 feet from CG of the column. Then we will deduct the half of the column, then we will found the CG. Yes, here is 1.5. 1.5 is CG of the column into 12 is multiplied by 12, which is converted to the inch, and 14 divided by 2. 14 is the column dimension and divided by 2 because we have taken the CG of the column, and we have found 11 inches. 11 inches. The 11 inches found from column face to the CG of the footing. Here is our eccentricity 8. the new eccentricity is 11 inches. I have forgotten to write in here, that's why all calculation calculated again uh, for precisely calculation. Now let's see. Here is the q max. Q max equal to p by bl plus, here is a plus, and 6p e into e is new e. Here will be new e. I have forgotten to write it new e, rather than I have used old e. That's why I have recalculated all the calculation. Okay, so we have put in all the value. Remember that the p had used the unfactored dead load plus live load. 71 is dead load and 11 is live load, and found 2.16, which is greater than the soil bearing capacity, and uh, another was minimum soil pressure is here will be minus, and we have found 0.80. Maybe I have forgotten to write here the value. The direction will be like this. The maximum value will be 2.16, which is greater than the soil bearing capacity, and minimum value 0.16, which is less than the soil bearing capacity. Okay, let's start. Here is the total factor load 1.2 dead load plus 1.6 live load. Here is the factor load, and we have used maximum the same value, and we have found the q max is 2.71. Here is the 2.71, and another is minimum soil bearing pressure will be minus, and the same value we have found 0.50, keep 0.5 keep feet square. Here is the keep feet square. So now we will check the punching shear, which will be occur d by 2 distance. So we have shown the figure. Here is the column, and c by d by 2 and d by 2, the total will be c plus d, and here is also in y direction on d by 2 c plus d by 2. So q is average. I have taken the average, maximum minus plus minimum divided by 2, and L by 2 we have and we have divide by 12 into 12, because we have seen the the dimension in feet square, but we will take this inch square. That's why we have divided by 12 into 12, and L into B is 8 into 8, which is multiplied by 12, is taken to inches. You need to convert it in inches. And C plus D we have shown here. The in along the x-axis is C plus D. Here is a C plus D, and another in the same way in y along the y-axis is C plus D. We have already shown the punching shear will be occur d by 2 distance. That's why C plus D and C plus d by 2 and d by 2 will be total D. Okay, now we have found here, and the area of perimeter 4 into C plus D into D. Here is the perimeter. Here is the C plus D is 1, C plus D in 2 and 3 and 4. That's why we will multiply 4 into C plus D, and we have multiplied the depth of here perimeter, depth of the footing. This is, that's why multiplied by D. The is called AP means perimeter of our footing. So now we will provide this formula for into F and C into AP, and found this formula, and now we will convert. Now we will compare this VP perimeter VP into 5BC. Then we will get the value of T. T is found 7.06 inches square. In the same way, we will calculate the value of T as shear checks. It will be occur D, distance of T. Here is the distance of T from column's surface of the column. Here the surface of the column will be D. So QT equal to Q minimum plus Q max minus Q minimum divided by 2, we have found 0.74, and qd2 is similarly we have used minimum and y2. Here is the two value is include here d1 y1 and y2. Let's see what is y1 and what is y2. Here is y1 we have calculated here. At first we don't know the value of d, that's why we have taken the minimum depth of footing is 12 for our new calculation, the calculation of y1 and y2. So let's see y1 equal to 2.5. Here is the point of 2.5, and it is multiplied by 2. We have seen where this is the 2.1, here is the 2.5. 2.5 is column face to the edge of the footing in the right side. Here is the, that's why we have 2.5, and minus c by 2. C by 2 is column center of the column, minus d. Here is the minus d. So what's happening here, we if we want to know that our value is given from column center to the here is 2.5. Now we will just we need this we need this portion only. How we will calculate this? Just we will take this value and deduct at first d by 2, c by 2, the column half of the column, and then deduct d. Then we will found this value is we called y. In the same way we will calculate the y2 is 5.5. we have found here already 5.5 here 5.5 from the CG of the column to the left portion. So if we want to know that or want to understand that how we will calculate, here is the columns CG of the column. My drawing is not that good. Here is the CG of the column, and the wall portion is 5.5. So we need to d by d to stand. That's why we will at first we will deduct d by c by column c by 2, and then deduct the d distance. Then we will found this portion is called d by 2 in 47 inches square. Okay, I hope you can got it. So in the same way we have found qd1 and qd2, and vu1 and qmax plus qd1 plus divided by 2, and share area if we put this value, the qd1 and qd2 here is here, and share area is b in 8 feet, and y1 we have already found 11, but we have putting here this value 2.5, here 2.5 minus column d by 2, column by 2 minus d. So this will be share area, and unknown will be d. In the same way we will calculate ud by 2 in left portion. This is b1 means right portion, and d by 2 is left portion. Here is the left portion. Left portion is q max d by plus q d2 divided by 2, and share area b plus y2. B is we have known the 5.5. Here is the 5.5 from CG of the column, and deduction by deduct the y2. No, b is 8 feet. Sorry, b will be 8 feet in multiplied by 11, and b is 8 feet, and y2 is 5.5. Here is the left portion of 5.5 is taken from CG of the column, and minus d minus column by 2, and deduct also d, and found this equation. If we compare this equation, then we will get that d value of 2.9 inches, and another d value is found on 8.4 inches square. So if we summarize the d value, then we will found the three type of d value, where one is 7.06, another one 2.96, and rest of and the last one 8.46 40 inches square. Now, but we will use 12 inches for our safety purposes. Now how we will calculate the reinforcement? At first we will know the q yield plus q minimum plus q max minus q minimum divided by L, and distance from edge of the column of the face. So q minimum we have found 0.5. At first we have let's see, here is 0.5 is the q minimum, and q max minus q minimum. Q max is already found in 2.75, and distance of the edge of the column to the face. Edge of the column is 5.5. We have seen the CG of the column to the right portion is 5.5. See, here is the given is this dimension, and we have deduct the only column half of the column, that is 14 divided by 2, and divided also 12, which is converted to the feet, into to feet. That's why we have found 1.86 kip square. In the same way, we have found the moment, which is 1. Half into 1.86. 1.86 is found here, the soil pressure, and 5.5 we have seen the 5.5 in the left portion of CG. From CG of the column is 5.5, and 2.5 is the right portion. The total will be 8. Okay, and now we have here is the 5.5 minus 14 divided by 2. 14 is the column, and divided by also 12 is converted to the inches to feet, and half is similarly half into 2.71. 2.71 is found the maximum soil pressure is here at 2.71, and deduct the value of 1.76 is found here, the overburdening pressure of soil. And also 5.5 we have seen the in graph, here is a 5.5 is CG from column to the left portion, and 14 is a column dimension divided by 2, and divided by 12 is also for converting the unit from inches to the feet, and into multiply by 1/3. As we have seen, the pressure will be trapezoidal, that's why we have used 1/3. Okay, and found the moment 23.16 kip feet per feet, and similarly as will be phi FYD minus a by 2, and found this value. The a value will be trial and error, and we have found the value of a equal to a equal to 1.68 inches square, and then value will be 0.44 inches square per feet. And the minimum reinforcement, we know that 12 to 200 into BD divided by FY, and found 0.48 inches square per feet, and we have using 16 millibar. It will be 16 millibar, and the area of 16 millibar 1.31 inches square, and number of bar will be 2 bar per feet. And if we want to spacing as into B into S, and found 7.75 inches square center to center. So we will provide 16 millibar in 7.75 inches square in both way, at top and bottom. So there is a exception is we have to remind that the reinforcement at top must be provided eccentric load. If we when we will impose the eccentric load or eccentric footing, that will mustly provide at the top of the reinforcement. On the other hand, we have calculated the only concentric load, that we have provide only bottom reinforcement, but there is the exception. We have to use the top and bottom both, because of there will be lots of twisting or movement will be induced here. So here is our final detailing. Here is 16 millibar at the rate of 7.75 inches square both way in top and bottom. Here is here. So if we this is my lecture is in. So if you have any question, then ask me. If we summarize in here at the very smallly, then we have found there at first eccentric single footing. There is a property line. 2.5 is the 2.5 is the client requirement, as there is no there is a small property. And we have seen that first we have found the layout, and for the eccentricity